Hello, it's Keith here, and this is the fourth in my YQuest programming tutorials. Now, YQuest is of course the little game that I wrote in my live streams, and I've been progressively porting it to different Z80 systems. Here you can see the new MSX2 version that was finished this week. Now, all the versions are downloadable on my website. They're part of the regular sources.z80, and we're going to be porting it to other systems. But in this tutorial series, we're going over the code and we're learning how it works. Now, the important thing to understand about it is this program was based on the original code in the Super Simple series, the joystick code to be precise. It used to move a little smiley face around. Well, it's now become an entire game, and the point I was trying to make with this is that you can start from a relatively simple beginning like that and turn it into something that's at least vaguely playable. This source, of course, is free to download, and you can modify it, do whatever you want with it, have fun with it. This is the fourth in the series, and we're going to be looking at the third section of the multi-platform code. There's only one more section left, and after that it's all the platform-specific stuff, depending on the different hardware. So let's go over the source code and let's have a look at the part we're going to be discussing today. Okay, so the start of today's episode, we're going to be looking at the draw object routine. Now, this code is actually a bit misleading in its title because it doesn't just draw the object, it actually handles the movement for the object as well. The first thing we're doing here is we're checking the collision program. A collision program of 250 or greater means that this object is not currently active, so it's not drawn and it's not calculated. That could mean it's dead, or it could mean the object has never been used at all in this level. For example, a bullet that's never been shot, or the 40th object on a screen with just 20 objects, something like that. So we're just checking that, and if we have no object to draw, we just return. Next, we're checking the program code, and the program code defines how the object moves around the screen. A program of 0 means that there is no movement, or that the movement is being handled in a special way. For example, the player is a moving object, but it's not handled with automatic movement. So in those cases, we're skipping over this section. But other objects will have a movement pattern, and these are basically the enemies. So we have various movement patterns here, and we're going to go through each of them ironically in descending order. So we're going to look at the most complex one first, but never mind. So program 6 here. This is the seeking object, so this will move closer to the player. So if the player's here, the enemy's here, it will gradually move closer to the player. It moves quite slowly. And so the first thing we're doing here is we're using the random number generator to select the chance of no movement occurring. We're just slowing down the movement so that the player has a chance of escaping. Next, what we're doing is we're loading the player XY position into H&L so that we can compare the current enemy location to the current player location. We're then getting the enemy location, and we're comparing, and we're either moving to the left or to the right depending on the position of the player compared to the enemy. Of course, if the player is already on the same X position as the enemy, then the enemy doesn't need to move, so we'll just stay horizontal. But if they're this way, they need to move closer this direction. If they're this way, they need to move closer this direction. So that's what's going on here. First, we're doing the X-axis here, and then we're doing the same for the Y-axis just here. So we're doing this sequence twice for both positions, and we're updating the X and Y position of the enemy accordingly. And that's really all it takes to move a enemy to seek onto the player, that piece of code there. Once we've done that, this program also defines that the enemy will fire. This is pretty much the hardest enemy in the game, so the enemy also occasionally fires. We're using the random number generator here. We're randomizing the acceleration because although we're actually overriding the movement, we're not using the acceleration to define movement in this case. The acceleration does also define the direction that the enemy bullets will fire in. This enemy actually fires in random directions, so we're randomizing the acceleration, and then we're using one of the bits of the random number to decide if the enemy is going to fire or not. We're just doing that there. Now, whatever happens, we then jump on to the part of the code that skips any kind of acceleration-based movement, because, as I say, we've actually defined the movement based on position. Program 5 is a little bit simpler. This is basically an enemy that randomly moves and randomly fires. So it's called a waiter because it doesn't move very often. So we're reading in a random number here, and we're just deciding what to do based on that random number. So we're either going to maybe fire, or we're maybe going to change direction here, just depending on the random number that is generated. You can see here we've got some AND masks, and just depending on the bits, we're kind of skipping around here and deciding whether to move or not. Program 4, kind of similar. Again, we've got this sort of indecisive element. We're using 3 bits here. If these are 0, then we're just skipping over. If they are not 0, then we're actually changing the direction of the object. So this is going to make the object change direction quite a lot. Now, program 3 is a shooting object. This kind of enemy doesn't change direction very often, but it will fire fairly frequently. You can see we've got a function called enemy fire bullet in all of these cases, which is part of the common code that handles the firing of an enemy bullet. Program 2 will change direction, but not very often. Basically, program 2 and program 3 are the same, just program 3 occasionally fires bullets, whereas program 2 never fires bullets. And program 1 will change direction quite a lot. It's quite an indecisive movement, so it tends to move around in fairly small areas and doesn't pose as much of a threat to the player as program 2, which will make huge sweeps across the screen. So by changing these parameters, we can alter the way in which an enemy fires and moves, just depending on how we're using the random numbers that are generated. Here's our new direction routine. So basically what we're doing here is we're using 2 bits of a random number, and if those bits are set, we are flipping the acceleration from positive to negative. Now this means that the acceleration is always the same, it's just the direction that acceleration is occurring is being flipped. The reason for this is that depending on our enemy type, some enemies move slowly, some enemies move fast, and these program codes don't care what the acceleration is, they're just care what the direction of that acceleration is. So this allows us some flexibility, because we can use program 1 on a very slow enemy and program 1 on a very fast enemy, because it's the speed being flipped, not being actually changed. So that's how we're doing things there. Now, if the enemy isn't moving, we need to load the X and Y position into B and C, because we're going to need B and C to be primed up for the drawing of the object. However, if the object is going to move, then what we're doing is we're still loading in from the X and Y position, but we're now applying the acceleration, adding the acceleration to the enemy position, and then updating the new position of that object. And we're also backing up the old position, because we're going to need to do some edge collision detection on that. Now, whatever happens, we're going to get to this position, and at this point we're checking the current position of the object and checking if the object has gone off the screen. If the object has gone off the screen, then we're going to need to bounce them back to the last valid object position, and also we're going to invert the direction of movement, so that basically if the enemy hits the side of the screen, they'll bounce back and keep going. A bit like a pong ball, if you kind of think of it like that. It'll bounce off the sides of the screen thanks to that negation code just here, and just here there's one for the X and one for the Y, of course. The reset code here, this is the same as our simple joystick example. We're loading in the last position that the object had, and we're just restoring it. We backed this up earlier before we did the acceleration movement. Now, finally here, we're just checking if the object is a bullet. If the object is a bullet and the object has reached the end of the screen, then we need to remove the bullet, and we also need to disable the object. And we're loading the collision program with 255 to do that here. And if you remember, we saw that all the way at the top here when we were checking that the object's collision program was lower than 250. And that's really how we're dealing with the movement of our objects here. Now, if you remember, when we were defining our object definitions here, we had the programs defined here, and you can see the program numbers, and the X and Y acceleration just here. And so if we want to change the movement of one of our objects, for example, this slow purple is being defined as being slow because of the combination of this move speed here, the X and Y move speed, and the program that makes it move randomly very quickly, whereas fast blue is changing direction much less often because it's using program 2, and it's fast because it's using an acceleration of 2 here. You can see, depending on the program code, we're affecting the movement of the object here, and Clouder here is using program 6, and so that is the only seeking object in my enemy definitions here. So there we go. That's actually all we're going to cover today. The program object handler is quite complicated, so I thought I'd go over that in a single lesson. It's meant this lesson's relatively short, but hopefully you've enjoyed it. We're going to be going over the last part of the multi-platform code next time, then we're going to move on to the platform specific. As I've already said, please go onto my website and download the source code, and you can have some fun with this yourself. And as I've said before, you're welcome to use the source code if you can to make your own commercial game. I really don't care, have fun with it. And if you manage to make something you can make money out of, good luck to you. So you're welcome to do whatever you want with it. You don't even need to give me credit if you don't want. So, if it's any help, have fun with it. Anyway, whatever you do, I hope you have fun with your programming, and I hope you manage to make something you can be proud of. So, thanks for watching today, and goodbye.